Okay, we are on the top of page 12 on the additional topics section, and we are going to start trigonometry today, how you normally think of trigonometry, sine, cosine, tangent. So we're going to do those definitions, and then we're going to look at the unit circle again. Okay, so it says, given a right triangle with an acute angle of t, the first three trigonometric functions are, we have sine t equals opposite over hypotenuse, cosine t equals adjacent over hypotenuse, and tangent t equals opposite over adjacent. Okay, so let's go ahead and break down this definition. We have a right triangle here. Okay, so here's our right triangle, and we have an acute angle t. They're both acute, so I'm just going to name this one acute. Okay, so I'm going to say this leg here is x, this leg here is y, and the hypotenuse is z. So I just chose random letters just because I didn't want to write opposite hypotenuse, adjacent hypotenuse over and over again. Okay, so sine t. Okay, so sine of this angle is opposite over hypotenuse. So the opposite side of this angle. So the opposite side would be x, hypotenuse is z. Cosine t, it says it's adjacent over hypotenuse. So here's our angle. The leg or side that's adjacent to it is y. So this is y over the hypotenuse z. And then tangent t is opposite over adjacent. So opposite, which is x, over adjacent, which is y. Okay, so those have to be memorized. Remember the common mnemonic SOHCAHTOA? Okay, so we have sine opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite adjacent. Okay, so try to remember SOHCAHTOA. Okay, example says, given the triangle shown in the figure below, find the value of cosine alpha. Okay, so let's say we have a right triangle here. We do not know alpha. Okay, let's say one leg is 13 and one leg is 14. Okay, and we want to find cosine of alpha. Okay, so cosine of alpha is adjacent over hypotenuse. So we're looking at this angle here. Okay, we want the leg that is adjacent to alpha. Okay, so adjacent would be 14 over hypotenuse, which we actually don't have. Okay, so we're going to have to figure out what the hypotenuse is. Okay, which we can do since we have a right triangle. So remember, for right triangles, we have leg squared plus leg squared equals the hypotenuse squared. Okay, so 13 squared is 169, I believe. 14 squared, which I'm going to have to do that in my calculator. 196. Okay, and then we'll add those together, get 365 here, which is a hypotenuse squared. Okay, I don't think, let me see if we can reduce 365. So square root of 365 is the hypotenuse. So this will be square root of 365. I'm trying to figure out if we can reduce this any, which I don't think we can. We can't get 25 to go into that. So I'm looking at 4, 9 maybe? No. So I'm looking at perfect squares. 4, 9, 16, 25 doesn't work. 36 does not work. 49 does not work. 64 does not work. 81 does not work. Okay, so this is as simple as it gets. Okay, so going back up to our solution, we have 14 over the square root of 365. Okay, so there's our solution. In the book, it's not going to be written like this. It's convention to not have square roots in the denominator. So to get rid of that, we're going to multiply the top and bottom by 365. Okay, we can, or square root of 365. We can do that because this is just 1, right? If you multiply by 1, it doesn't change the answer. So if we were multiplying by 8 over 8, that's multiplying by 1. So we're multiplying by square root of 365 divided by square root of 365. So we're multiplying by 1, so we can easily do that. Let me put a little box around this. Equals, so we have 14 times the square root of 365 divided by, this would just be 365 down here. So there's our solution. And that would be the solution that the SAT would give you. Okay, 3 more functions are, we have secant t, which is a hypotenuse over adjacent. Cosecant t is, oh sorry, I didn't move this over. Cosecant t is hypotenuse over opposite, and cotangent t is adjacent over opposite. Okay, notice that these are just flips of sine, cosine, and tangent. So secant t is hypotenuse over adjacent. So that's actually just the flip of cosine, 1 over cosine t. Cosecant is the flip of sine t, so 1 over sine t. And then cotangent is the flip of tangent, so 1 over tangent t. Okay, so if you have these first 3, okay, you can always find the next 3 trig functions. Okay, so again, we have noticed that. So these have to be memorized also. Okay, example, it says, using the triangle shown below, evaluate all 6 trig functions. Okay, so let's go ahead and draw a right triangle. You have to have a right triangle here. Sometimes I'll see students trying to do this with any triangle, so be careful with that. This only works with right triangles. Okay, so let's say this leg is 3, this leg is 4, and that forces the hypotenuse to be 5. And let's say our alpha is here. Okay, so we want sine alpha. Okay, so remember sine is opposite over hypotenuse. So that would be 3 over 5. Cosine alpha is adjacent over hypotenuse, so adjacent leg would be 4 over hypotenuse, which is 5. Tangent of alpha is opposite over adjacent, so 3 over 4. I'm going to do cosecant first, okay, because it's the reciprocal of sine. Okay, so we're just going to flip this, flip sine, so 5/3. Secant of alpha would be the flip of cosine, or 5/4. And then cotangent of alpha is the flip of tangent, which is 4/3. Okay, so those are all of our 6 trig functions for that triangle. Okay, moving on to page 13. Okay, we've got some special angles here. So far we've just been using angle alpha, angle t. Okay, we don't know what the angles are. Okay, but now we're going to do some very specific angles. Okay, so we have special angles, pi over 6, pi over 3, pi over 4. Okay, so we have that sine of pi over 6 is 1/2, which is also the same as cosine of pi over 3. We also have that sine of pi over 3 is the square root of 3 over 2, which is the same as cosine of pi over 6. Okay, so notice that these have just flipped. Sine of pi over 4 is equal to the square root of 2 over 2, which is equal to cosine pi over 4. So those are actually the same. Remember that what these angles are. Pi over 6 is 30 degrees, pi over 3 is 60 degrees, and pi over 4 is 45 degrees. Okay, so remember we went from the unit circle, which let me pull that up. Or we actually didn't define it as the unit circle, we just have the angles here. Okay, so remember that these two were the same. So pi over 6 is the same as 30, pi over 4 is the same as 45, and pi over 3 is the same as 60. Okay, so let's do an example. It says find the unknown sides of the triangle below. Okay, so let's say we have this triangle. Here's a right angle. We have this is A, this is C. We're going to have this leg be 7. And then we'll have this angle be 30 degrees. Okay, so we cannot figure out the sides by using Pythagorean's theorem because we only have one. Okay, so we have one side, one angle. So we can use our definition of our trig functions to find those other sides. Okay, so let's just use, here's our angle. We have opposite. So let's use sine. Okay, you could have used tangent, but now we can use sine. So sine of 30 degrees, so sine of our angle is opposite over hypotenuse. So 7 over c. Okay, sine of 30 degrees is the same as sine of pi over 6, okay, which is 7 over c. We can go back up here. Sine of pi over 6 is 1/2. So we have 1/2 equals 7 over c. Okay, cross multiply, we have c equals 14. Okay, so instead of c, we have 14 here. Now we could go ahead and use Pythagorean's theorem to check, but I think this is actually easier than using Pythagorean's theorem. So we can instead use cosine. Since we have an a here, this is adjacent. So let's go ahead and use cosine. So we have cosine of 30 degrees is adjacent, which is a, over the hypotenuse, which is 14. So 30 degrees is cosine of pi over 6, which is a over 14. Cosine of pi over 6, coming up here, is square root of 3 over 2. So square root of 3 over 2, which is a over 14. Okay, so this would be 14 square roots of 3 equals 2a. So a, so I'm dividing by 2 on both sides here, would be, looks like 7 square roots of 3. And then let's go ahead and do decimal form for that. I just want to make sure it makes sense. So it should be less than 14 since it's a leg. I'm just checking to make sure it makes sense. So I got about 12.1. Okay, which I'll go ahead and put that. 12.12. Okay, the SAT would probably give you this answer. It just depends. Okay, next example says to find the height of a tree. A person walks to a point 30 feet from the base of the tree. She measures an angle of 57 degrees between a line of sight to the copy of a tree on the ground. As shown below, find the height of the tree. Okay, so I'm going to draw this out for you. Okay, so we have the height of a tree, and then walking 30 feet. Okay, we don't know the height of the tree. Let's just make that x. And then we have a line of sight for 57 degrees. Okay, so we want to figure out the height of the tree here. Alright, so we have a right triangle. The tree with the traveling distance makes a right triangle. And so we don't have the hypotenuse. We can't find the hypotenuse. But we do have two sides. We have x and we have 30, which is the legs. Notice our 57 degrees is not one of the ones we know. Okay, so sine and cosine, you could use that, but it's not really going to help that much because we don't have an exact angle that we know. Okay, so we'll just go ahead and use tangent since we have two legs. Okay, for sine and cosine, we would need to have the hypotenuse. We have two legs here, so I think it'll be faster if we just use tangent. If you use sine and cosine, it's going to be 2 steps, okay, which is fine. You can do that. So we have the tangent of 57 degrees is opposite over adjacent, so x over 30. Okay, so unfortunately, this isn't an angle that we know, but we can use our calculator. So if you turn your calculator on, we're just going to be using this tangent button here of 57 degrees. Be careful though, and you'll need to do this with all of them. You'll need to go to mode first and change, so you should see radian degree here. Make sure you change it to degree if you're in degrees. Now if it was pi over 6, you would want to keep it in radians. Okay, so we're doing tangent of 57 degrees. Okay, and again, make sure you change it to degrees. So tangent of 57 degrees is that, okay, which I'm going to go ahead and cross multiply here so we can just do this all in one step. So we have x equals 30 times tangent of 57 degrees. Okay, so I'm just going to take this number and multiply by 30. So I got x is approximately 46.2 feet. Okay, so that's how tall the tree is. Okay, so I'm going to put the calculator work up here again. So do tangent of 57 degrees, make sure you're changing the mode to degrees, not radians, and then I just multiplied by 30 to get the solution. There'll probably be one like that on the SAT. Okay, next, so bottom of page 13, we're going to look at the unit circle, which we've looked at a little bit, just the angles. It says the unit circle is a circle with center at the origin with radius 1. So let's go ahead and draw that. So we have an XY. Okay, our center is here. So we've looked at this before. This is in standard position. Okay, but now we're going to have a circle with radius 1. So when we did all of those angles, we didn't define a radius. Okay, we just, went from the center. But now we're saying this radius is 1. Okay, so this point here would be 1, 0. Okay, it says the angle in radians that T intercepts forms an arc of length S. Using the formula S equals RT and knowing that R equals 1, we see for that the unit circle S equals T. So that means for any angle T, we can label the intersection of the angle and the unit circle by its coordinates XY. Okay, so this means take any angle, the intersection of an angle and this circle gives us a point, and it's XY. Okay, X is cosine T, Y is sine T. Okay, so let's just go ahead and draw a picture. This is XY here, so I want to make sure you understand that. Okay, so I'm just saying we're just making this XY. This is any point. I just randomly chose this angle. Okay, drop this down. Okay, we chose a random angle T. Okay, when you extended it and found the intersection with the circle, you have just a random point XY. When you drop this down, this makes a right angle. Okay, this length here is X, okay, because you go over X up Y. So this here would be Y. Okay, this length here is the radius of the circle, so that is 1. Okay, so let's do sine T and cosine T. Sine T would be opposite, which is Y, over hypotenuse, which is Y. Cosine T is adjacent over hypotenuse, which is X. Okay, so that's how the XY becomes cosine T, sine T. So this is cosine T, sine T. Okay, again, you need to memorize that. X is cosine T, Y is sine T in the unit circle. Okay, moving on to page 13. Okay, it says point P is a point on the unit circle corresponding to an angle of T as shown below. Find cosine T and sine T. Okay, so I'm going to go ahead and draw, I'm going to actually come up here and draw the unit circle. So the picture is here. Okay, so let's say we have some point here. Okay, so we're given point P, and let's define this as 1/2 square root of 3 over 2. Okay, so we're given a point. Okay, so this, okay.
Then we can find, actually we don't need to know what T is. We can immediately find cosine T and sine T. Okay, so coming down here, cosine T, remember, is just the X of our coordinate that corresponds to this angle. So cosine T is the X value, which you can see is 1/2. Sine T is the Y value, which you can see is square root of 3 over 2. Okay, so once you have defined an angle and you have the point, that's just going to be cosine T, sine T as XY. Next example says find cosine of 90 degrees and sine of 90 degrees. Okay, so I want to draw a picture of 90 degrees. Remember, and this is a unit circle. This looks terrible. 90 degrees is here. Okay, so remember this is the unit circle, so it has radius 1. So this point would be 0, 1. Okay, so we have cosine T is the X value, which is, I'm sorry, not T. We can do 90 degrees here since we know what the angle is.
cosine of 90 degrees is the x value, which is 0. And then sine of 90 degrees is the y value, which is 1. Okay, next we have a table. These are all of our important angles. This needs to be memorized. Okay, definitely memorize this table. There will be a lot of questions in the trig section of your SAT, and it's mostly this. Okay, so we found 90 degrees on our own. Okay, you could actually go through and find each of these on your own. Okay, but it's probably easier to just memorize. It's going to be faster for the SAT if you memorize. Okay, so let's just quickly go over these. So first row here, we have in degrees, we have some important degrees that you'll see a lot on the SAT. So we have 0 degrees, 30, 45, 60, 90, 180, and 270 degrees. Remember, 360 degrees is the same as 0. In radians, that's 0, pi over 6, pi over 4, pi over 3, pi over 2, pi, and 3 pi over 2, okay, which we can go back to the circle that we drew a couple pages before and check that. Okay, sine of these angles here. So 0 degrees, okay, coming back up to that picture, that would be here. Sine of 0 is 0. Sine of 30 degrees, or pi over 6, is 1/2. Then you have square root of 2 over 2, square root of 3 over 2, 1, 0, negative 1. Okay, same with cosine. They're a little bit different. And then you have tangent here. Okay, so definitely memorize those. Before we move on, which I guess I didn't define this as this, but this probably needs to be memorized too. Tangent of theta is actually sine theta over cosine theta. Okay, so you actually don't need to memorize tangent. Memorize sine and cosine, and then your tangent will be memorized. Okay, so for example, if you want to know what tangent of, let's just do pi is. Okay, so you would do sine pi over cosine pi. Okay, sine pi, so you have sine of pi is 0, cosine pi is negative 1, so tangent of pi would be not negative 1, 0. 0 here, which you can check. Tangent of pi is 0. Okay, which you guys need to memorize this too if you haven't already. So tangent is sine over cosine, which if you go back to our original definition of tangent, okay, you can actually see that. So we define tangent as opposite over adjacent, okay, which is actually sine over cosine because the hypotenuses would cancel. Okay, it says to find the cosine and sine of the angles other than the listed above, we use our calculator. Most calculators can be set into degree or radian modes, so make sure you have the calculator set to the correct mode. Okay, so again, that's just a note saying that make sure you're seeing if you're in degrees or radians. So if we want to find like tangent of 89 degrees, okay, that's not a common one. We would evaluate that on our calculator in degrees. If we wanted tangent of pi over 12, that's also not a common one. You would set this to radians. Okay, so using this table, I want to go ahead and fill in some more from the unit circle. Okay, so unit circle, we'll go ahead and go over a couple more quadrants, okay, using this table. So let's go ahead, and I just turned my sheet over. There's not room in your work for this. So turn it over so we have some more. Okay, so we have 30, 45, 60. Okay, these are our common angles. Okay, of course we have 0, and then this is 90, which we don't need to write. Actually, no, I won't write in because you know this is 90 degrees. So let's go ahead and put our points in here. Okay, so this point would be 1, 0. Okay, 30 degrees. Okay, you remember that is cosine, sine. So looking at our table of 30 degrees, we have cosine, which is square root of 3 over 2, sine, which is 1/2. So square root of 3 over 2, 1/2. Okay, 45 degrees. So looking at cosine and sine, that would be square root of 2 over 2, square root of 2 over 2. 60 degrees. We have cosine of 60 degrees, which is 1/2. sine of 60 degrees is square root of 3 over 2. Okay, this point here would be 0, 1. So remember our radius is 1. Okay, so that's how we get that. Okay, so that's basically filling in the unit circle. You have this table here. Okay, so let's go ahead and do some more important angles. So remember from the last one we did, we also filled in the next couple angles, which I'm actually going to change these into radians because it's probably more common to put them in radians. So we have pi over 6, pi over 4, and this is pi over 3. This is pi over 2. Okay, so this angle, we can easily do, that would be, I'm going to do the middle one first. So this would be 3 pi over 4. This one would be 2 pi over 3, and then this one, so I'm just moving up here, would be 5 pi over 6. Okay, and then this angle is pi, or 180 degrees. Okay, so we can go ahead and fill in here. Okay, and they're going to correspond exactly to these points here, except we're going to have some positives and we're going to have some negatives. Okay, let's do pi first. I think that one's pretty easy. So we have negative 1, 0 for pi. Okay, now let's do the square root of 3, I'm sorry, not square root of 3, 3 pi over 4. Okay, it's going to be exactly this point, okay, except 1 is going to have to be negative, okay, because we're going back. So our x is negative, so this would be square root of 2 over 2, and then the y is the same, square root of 2 over 2. Okay, so negative square root of 2 over 2, because you have to go back for the x and then up for the y. Okay, for 2 pi over 3, okay, again, this is still cosine sine. Okay, so it's going to be this point. It's going to correspond to the over 3. Okay, except 1 is going to be negative. Okay, again, the x will be negative. So this would be negative 1/2 square root of 3 over 2. And then your 5 pi over 6 would be negative square root of 3 over 2. And then, I keep forgetting to put the negative, and then 1/2. Okay, so your denominators correspond. So you can see that over 6, the points are the same, except you've got some negatives and some positives. Pi over 4, pi over 4, pi over 3, pi over 3. The points are the same, except you have to think, okay, which one's positive and which one's negative. Okay, let's go ahead and just do all the quadrants. Okay, so you have 3 more here, and then 3 more here. So let's fill this in as radians. I just think it's a little easier as radians. Okay, so I'm going to fill in the over 4s first. 4 pi over 4 would be pi, so this one would be 5 pi over 4. 6 pi over 4 is this, which is 3 pi over 2. And then we would have 7 pi, yeah, because this is 6 pi over 4. So 7 pi over 4 here. Yeah, so we have 1, 2, 3, 4, 5, 6, 7. Okay, 8 pi over 4 would be 2 pi or 0. Okay, so now for the 6's, we have 5. This would be 6. This next would be 7 pi over 6. 8. This one is going to be over 3. So we'll skip that. And then we would have 11 pi over 6 here. Okay, so if you want to look back at your radians, go back to our previous, I think this would be part 4. So yeah, go back to part 3, look over this again. Okay, for 2's we have, for over 3. So we have 2 over 3, 3 over 3. So this would be 4 pi over 3. And then 5 pi over 3 would be the last one. Okay? Alright, so let's go ahead and fill in the rest of these points. Okay, so over 6, we have the same denominator as pi over 6. So we're going to have this point, except we're in the third quadrant here, 1, 2, 3, so they're both going to be negative. So negative square root of 3 over 2, negative 1/2. Okay, for 5 pi over 4, same denominator as the pi over 4. So it's going to be this point, except they'll both be negative. Okay, both negative. I keep forgetting negative signs. And then for 4 pi over 3, it's going to be the same as the pi over 3, which is this point, except they'll both be negative. So negative 1/2, negative square root of 3 over 2. Okay, now this one is easier because it's actually on the radius here of the circle. So this would be 0, negative 1. Okay, now we just have to fill in these. This one is over 3, so it's going to be this one. We would have positive x or positive cosine and then negative sine. This one, same way, so same as 7 pi over 4, so same denominator as this. So this point, except the x is positive, the y is negative, since we're going over positive down. And then over 6 would be this point. Okay, again, x is positive, the y is negative. Okay, so this is the unit circle. If I were you, instead of memorizing this table, I would memorize this picture. So after this video, which we're almost done, go ahead and get another piece of paper and practice again. Okay, so practice, practice, practice with this circle. If you have this circle memorized, basically everything you do with trig on the SAT will be simpler. Okay, so memorize this, okay, and then this table will just come with that. Okay, so we're going to go ahead and stop there. And I think the next video will have distance formula and circles, and then we'll finish triangles, and I believe we will be done.